Hi guys, welcome back to my video. So for today's video, we'll talk about satellites. Well, satellites are bodies in space revolving or moving around larger bodies through a curved path. And this curved path is what we call an orbit, okay? An orbit is the curved path through which satellites move around larger bodies while in space. So basically, there are two types of satellites. There are artificial satellites and natural satellites. And I don't think I need to tell the difference between artificial and natural, do I? But anyway, the examples of the natural satellites that we do have are the Earth and the Moon. So get to realize, I don't have artistic skills that I hope this can do. So for example, this is the Earth, right? This is the sun, the sun. The sun is larger than the earth, okay? So this is the sun, and then this is the earth, okay? Like this is, and since the earth revolves around the sun in a curved path, that makes this the orbit, and this makes the earth a satellite, right? But then we also have the moon. The earth is larger than the moon, so when the moon revolves around the earth, and then this in a curved path that makes it the orbit, it makes the moon also a natural satellite, okay? So basically those are the examples of the natural satellites that we do have. But specifically for this video, I'll talk about artificial satellites. So artificial satellites are machines which are launched into space to orbit larger bodies in space in order to carry out a specific purpose. And we get to realize that there are different kinds of artificial satellites. For example, we have communication satellites. These are ones that enable us receive phone calls, broadcast television signals, and also internet connectivity, right? Then we also have weather satellites. Under weather satellites, they are what enable us to be able to predict or see weather forecasts, right? And then we also have navigation satellites. So under this is where we find stuff like the GPS, the Global Positioning System. And then we also have scientific satellites. Like under scientific satellites, we get to realize stuff like the Hubble telescope. Like these are satellites which scientists use for the exploration and research. For example, the Hubble telescope, it takes pictures of the universe, so it enables scientists to determine the expansion rate of the universe, right? So we get to realize that, remember in the beginning of the video when we talked about the orbit, the curved path which the satellites take once launched into space, you need to realize that all the different kinds of artificial satellites can't just all go under one orbit, like can't all fall under one path. So that means they have to be more than one path, more than one orbit in space. And that's why there are three kinds of orbits in space. So we have something called the low Earth orbit, the middle Earth orbit, and the geostationary Earth orbit. Okay, so these are there are three kinds of orbits. Well, as I earlier stated, my artistic skills aren't that good enough, but I hope this still does help. So as you can see here, we have the Earth, right? So this is the Earth, and then we are gonna start with the lower Earth orbit. So this is the lower Earth orbit. So it's located 320 kilometers to 1,000 kilometers above sea level. So it doesn't exceed 1,000 kilometers. So satellites under the lower Earth orbit, for example, the Hubble telescope, it's located in the LEO, right? So the LEO is not more than 1,000 kilometers from sea level, right? So this is the first. So from the LEO, we go to the middle Earth orbit. So the middle Earth orbit starts from 2,000 kilometers above the sea level. So this is here. And under the NEO, that's where we find stuff like the navigation satellites, right? They're located here, 1,000 kilometers above the Earth. So this is the Earth. And then we have the largest, and one that's farthest from the Earth. As you can see, the geostationary Earth orbit. It starts from 35,786 kilometers above sea level. So like it's really far away from the Earth's surface. And under the U is where we get to find the communication satellites, right? So as we've earlier seen, so that's like basically how the three kinds of orbits that are found around in space. We had the LEO, the low Earth orbit, which is located less than 1,000 kilometers from the Earth. And then we had the middle Earth orbit, which was starting from 2,000 kilometers. And then we had the largest. So don't forget the largest, the geostationary Earth orbit. It was the largest. But then that leaves us with the question, what's the mechanism behind the satellites? How do they actually do work? So that's the next thing we're going to discuss. So how do satellites actually do work? So satellites work under a principle of, they undergo two processes. So there's something called uplinking and downlinking, right? And a satellite can't work without the help of ground stations. And ground stations are points located in different points of the Earth. So the satellite's in space, but the ground stations are on the Earth, right? So basically, this is how a satellite does work. So let me bring the photo and the pic. So remember, as earlier I told you, my artistic skills weren't that good, but I hope they still can do help. So we have the ground stations. This one's down here. So it all starts from the ground station. A ground station sends a signal to a satellite, right? So this signal can either be in form of data, voice, or video, right? So this signal is transported to a satellite through an uplink, right? This is the uplink. The signal, either in data, voice, or video, is transported to a satellite in space through an uplink, right? So when it reaches the satellite here, the satellite is able to receive this uplink signal through its antennas, right? So once it has received the uplink signal, it amplifies the signal and processes it, and it actually even converts its frequency. Can you imagine? So that it doesn't collide with another uplink signal. So to avoid collisions, it even converts the frequency to a different one. Once it's done doing that, this amplified signal is then sent to another ground station on another point of the Earth through a downlink, right? Through a downlink, this amplified signal is sent to another ground station. And once it reaches the ground station on a different location, on an opposite location of the Earth, this ground station then processes it for distribution. So this distribution can be in a number of ways. It's either through broadcasting as television signals, or through internet connectivity, or relaying a phone call. So basically, for example, a phone, let me give you an illustration of a phone call. So when someone in an opposite part of the Earth makes a phone call to another person on the other side of the Earth, it starts from a ground station in that country. It all passes through the uplink to the satellite. It's processed, amplified, and through a downlink, it goes to a ground station here. So once it reaches a ground station in the other location, the opposite side of the Earth, this ground station sends these amplified downlink signals, or for example now, it's a phone call, it relays it to the receiver. So a receiver on the other side of the Earth is able to hear the information being conveyed by a person on the other side of the Earth through satellite communication. So that's how a communication satellite located in the geostationary Earth orbit is able to facilitate communication. So there we have seen how, so we've got to realize and see how a satellite works, what a satellite is. We've got to define it. We've got to know the orbits, like the paths through the different various satellites take as they're orbiting a body. So a quick review. So what was a satellite? A satellite was a body revolving around a larger body in a curved path called an orbit. So don't forget the orbit. It's an important thing. It's the curved path through which all satellites take. We got to realize that official satellites, these ones are machines which are just actually launched in space to carry out a specific purpose, right? We got to realize the navigation satellites, we got to see the communication satellites, the weather, and the scientific, right? And then we also got to see the working mechanism of our communication satellites. So basically, all satellites have the same working mechanism, just kind of differs a little bit, but for this video, I mostly focused on the communication satellites, and I hope it did help a bit. So thank you so much for your time. I hope you loved the video. I hope it helps you. And please like and subscribe. Have a good day.